In this video, we want to learn about factorials. Let us start by an example. Factorial of 4. 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. So 4 factorial is 24. The notation for factorial is this exclamation mark. And what is factorial in general? Factorial of a number is the product of all positive integers starting from that number and counting backward to 1. For example, as you can see, 4 factorial is 4 times 3 times 2 times 1. What is 10 factorial? 10 times 9 times 8 times 7 and continue up to 1. What is 3 factorial, for example? 3 factorial is 3 times 2 times 1, 6. What is 2 factorial? 2 times 1, which is 2. What is 1 factorial? Because we start from 1 and we multiply backward up to 1, so it's just 1. Now we know what is factorial, what is the notation of the factorial. Let's see what is general definition of n factorial. N factorial, based on the definition that we learned, is n times n minus 1 times n minus 2, and we continue this up to when we get to 1. For example, when we have 5 factorial, we start from 5, then we multiply 5 by 4, so n times by n minus 1, 5 times by 4, then 5, 4, this plays the role of 3, then 2 and 1. So n factorial is defined in the form of n, so starting from n, and we decrease n times by n minus 1 times by n minus 2, and we continue this, we go backward till we get to 1. This is definition of n factorial. And by definition, we have defined 0 factorial to be equal to 1. This is based on definition. Otherwise, maybe you think by yourself, why it should be 1? We have 0 and it should be 0 times by anything is 0. But it is defined in this way in math for some good reasons. So for any other number than 0, we follow this general rule. N times n minus 1 times n minus 2 and so on. But only for 0 we have defined it to be equal to 1. As we did before, we want to calculate 4 factorial. We know already 4 factorial is 24. It's good to memorize these small numbers, factorial of these small numbers. Let's do the calculation again. 4 times 3 times 2 times 1, which is 24. 3 factorial is 3 times 2 times 1. So 3 times 2 times 1, which is 6. 2 factorial, 2 times 1. 1 factorial is 1. 0 factorial, we have defined it 1. So this is 6, 2, 1, 1. 6 plus 2, 8, 8 plus 1, 9, 9 plus 1, 10. So the answer of this is 10. Now look at these examples. We want to do some simplification here and we want to find the value of these expressions. 6 factorial divided by 4 factorial. Based on the definition, what is 6 factorial? 6 factorial is 6 times 4 times 5 times 4 times 3 times 2 times 1. What is 4 factorial? 4 factorial is starting from 4, then 3, then 2, 1. And now if you look at the numerator and denominator, we have some common terms and we can cancel them. You don't need to multiply numerator terms in numerator and terms in denominator. It's easier to cancel common term from numerator with denominator. 2 with 2 cancels, 3 with 3 cancels, 4 with 4 cancels. And in numerator only we have 6 times 5. 1 is, we can ignore 1s because 1 times by anything is same thing. 6 times 5 in numerator is 30, so this equals 30. But is this the best way of doing this question? For simplifying 6 factorial over 4 factorial, there is basically a better way. This is not best way of doing this example. Let me show you how we can simplify 6 factorial divided by 4 factorial in a better way. So we want to simplify 6 factorial by 4 factorial. It's same thing as this process, but it is a little better. What is 6 factorial? We know what is 6 factorial. 6 factorial is basically this. 6 times 5 times 4 times 3 times 2 times 1. But here, attention, we want to divide 6 factorial by 4 factorial. Instead of writing 6 factorial and opening 6 factorial in this way, we can do it a little in a different way. Please pay attention. 6 factorial is 6 times 5. Here I am going to stop for a moment, and I know that I want to divide 6 factorial by 4 factorial. Instead of writing all of this up to 1, what do we have here? I know I want to write 4 here, then 3, then 2, then 1. But instead of writing all of this, 4 times 3 times 2 times 1, right now we are familiar with factorial. It's better not to waste our time for writing all of this. Simply we can write, instead of that we can write 4 factorial. 4 factorial is exactly this. Why I am doing this here? Because I know that in the denominator also I have 4 factorial, and immediately I can cancel 4 factorial with 4 factorial. This is the better way to doing this question. So I open this based on the definition of factorial, and I'm writing this 6, 5. Then I'm not going up to 1 like here. Because I know that I want to simplify this 4 factorial, I am stopping here at 4 because I have 4 factorial here. And then when I write 4, then I put exclamation mark here, which is 4 factorial, and I stop here. I'm not going up to 1. This is the better way. As you can see, this solution is shorter, at least a little shorter, over 4 factorial. Now 4 factorial with 4 factorial cancels, and we have 6 times 5 in numerator, which is 30. Maybe you think that these two solutions seem similar, and maybe the first solution is easier. Let me show you an example here that would prove for you that definitely the second solution is much better. Suppose you want to simplify this. 100 factorial divided by 90, for example, 8 factorial. If you want to write 100 factorial, you have to write 100 times 99 times 98 times 97 times 96. It takes forever to write up to 1. And then you want to open this and write 98, then 97, 96, 2, 1. Then you want to cancel common terms. Instead of this, I recommend you to learn to simplify expressions with factorial in this way. We have 100 factorial. We say, okay, 100 factorial is 100 times 99. Because in the denominator we have 98 factorial, we stop here immediately and we say we are not going to write 98, 97, 96 in numerator. Just we write 98 factorial. This is instead of writing all of those terms. And in the denominator we have 98 factorial. These two cancel, and we have 100 times 99, which is 9,900. This is the answer of this example. Now look at the next example, which is very important. Let me remind you what is definition of n factorial. N factorial is n times n minus 1 times n minus 2, and so on up to 1. What happens in this definition? When we start from n factorial, first we write n. Then in the next term, which we multiply by n, we have n, same value, but 1 unit less. N, then n minus 1, like here. When we have 100, then we have 99, which is 1 less than this. If you think about this, 100, the next term is basically 100 minus 1, which is this 99. So, when we have n factorial, in the definition we have n, in the next term we have n minus 1 unit less. Whatever is the previous unit, in the next unit we have 1 unit less. Now, let's see how we can simplify this. In numerator we have n plus 1 factorial. Based on definition of factorial, we have to start from that number. When we have 100 factorial, we start with 100. When we have 98, we have to start from 98. When we have n, we start with n, then n minus 1, then n minus 2, and so on. So for n plus 1 factorial, we start with n plus 1. What we have to put in the next bracket? 1 unit less than this. N plus 1. 1 unit less, 1 with 1 cancels, so we have n here. In the next bracket, we have 1 unit less than the previous one. Here is n. What is the next term? N minus 1. N minus 2. And this goes for up to 2, 1. What about denominator? Denominator is n factorial, and we know what is n factorial. N factorial is n times n minus 1 times n minus 2, and so on up to 2 and 1. Everything from numerator, almost from denominator, cancels except this n plus 1, and so the answer is n plus 1. So we simplified this, and this is the answer. Now let me show you again the better way for simplifying this expression given here. Let's do the question again, but in a better way. N plus 1 factorial is definitely bigger than the n factorial which is in the denominator. So we start with opening the numerator. Based on definition of factorial, we know that n plus 1 factorial should be n plus 1. Then it should be n, then n minus 1, then n minus 2, and so on. But again, similar to the example which I explained here, I'm not going to write all the terms in numerator. Instead of that, when I start from this value, whatever is here, then I know that after that I have to write n, then n minus 1, then n minus 2, and so on. And I know that I want to simplify it with n factorial. So instead of writing all of those terms in numerator, simply we can write n plus 1 times by n factorial. Why we have to waste our time for writing all the terms that are equal to n factorial? So whenever you start from a number, whatever it is factorial, you can open it, and whenever you want, like here, you can stop. We started with n plus 1. We decrease this value by 1 unit, we get n. Here I don't want to continue forever, so I decide to stop here. When I decide to stop, I put exclamation mark here. Now we write the denominator. This cancels with this, and the answer is n plus 1. This is the better way for simplifying this expression. Now look at these examples. N plus 3 factorial divided by n factorial. Because again, numerator is bigger, the bigger factorial is in numerator, we open the numerator. Based on definition of factorial, it's equal to n plus 3 times n plus 2 times n plus 1. What's happening here? We start with this number, then 1 unit less than n plus 3 is n plus 2. 1 unit less than this is n plus 1, and so on. Here, after n plus 1, what we have? N. Then n minus 1. But because in the denominator I noticed that I have n factorial, I'm not going to continue writing this forever. I want to stop here. I would stop here and n factorial. We don't need to write n, n minus 1, n minus 2, and so on. And in the denominator we have n factorial. This cancels with this, and the answer is n plus 3 times n plus 2 times n plus 1. And you don't need to multiply these brackets by each other. Leave it in this form. Look at the next example. We keep n factorial here. For the next term, n plus 1 factorial, we know that it is n plus 1 times n factorial, all over n factorial. Look at the numerator. In both of these two terms, we have this common term, so we can factor the common term between these two. So this equals to n factorial times y. From the first term, if we factor this, we have only a 1. From the next term, we have n plus 1 all over n factorial. Now, if we cancel these common terms, in numerator we have 1 plus n plus 1, which is n plus 2. This is the answer of simplifying this expression here. Look at the next example. 2n factorial over 2n plus 1 factorial. Here we notice that the denominator is the bigger factorial, because numerator is 2n, but denominator is 2n plus 1 factorial, so it's 1 more. So here we are not going to open numerator. We leave it as it is, 2n factorial. But in denominator, we have 2n plus 1. So for example, this is like 20 factorial, but this is 21 factorial. You can think it that way. So we have to open the denominator. Based on definition of factorial, this is 2n plus 1. What is the term after 2n plus 1? 1 unit less. 2n plus 1. 1 unit less. This cancels with this. So it would be 2n factorial. You can continue writing 2n, then 2n minus 1, then 2n minus 2, 2n minus 3, and so on. But there is no reason to write all the terms. We have a notation, we have factorial definitions. Just write 2n factorial. Now, cancel common terms. And the answer is 1 over 2n plus 1. Look at the next example. Numerator is bigger. 2n plus 1 factorial is 2n plus 1. Then we have 2n. Should we stop? No, because the denominator is smaller. We continue decreasing inside the bracket. 2n plus 1, 2n. The next would be 2n minus 1. Now that we have exactly this, we stop here and we put exclamation mark or factorial notation here. And then we keep the denominator. These two cancel, and the answer is 2n times 2n plus 1. I change the order of these two terms because this is multiplication. The order of multiplication, the order of the brackets doesn't matter. I hope by watching this video now you are a little familiar with factorial definition, how we can simplify expressions involving factorial and other things. If you like this video, please subscribe to my channel and see you in the next videos.